Okay, linearization video part one. Um, I would like to, before I start linearization, okay, before I start doing the Newton's method of linearization, there is a linear model I would like to talk about in this video, and I do some activity or exercise to practice this. First, f should be differentiable at. If f, for example, is differentiable at x equal a. If it is differentiable at a point, at a certain point, uh, this means it has derivative. Its derivative at that point is equal to the limit as x approaches this point of f of x minus f of a over x minus a, right? And for the value of x approaches a, near to a, f prime of a is approximately equal. F prime of a will be approximately equal this value, which is f of x minus f of a over x minus a. This is the principle of differentiability, right? Okay, if we a cross product to find f of x here, so f of x simply minus f of a will be approximately equal, right? Approximately equal f prime of x into x minus a, or f of x is equal, take f of a minus f of a to the other side, it will be f of a equal, not equal, plus f prime of x into x minus a. Okay, so therefore uh, uh, L of x is a linear model. We can say that L of x is a linear model of this linearization, right? And we can take it equal this value, which is f of x plus f prime of x into x minus a. This is the linear model we need for linearization. And linearization is something to find the error when we are finding uh, this root of this. We will see later about the roots. So I'm not going to talk about the roots here, but y equal this value, which is f of a plus f prime of x into x minus a, is simply is the equation of the tangent at x equal a. This means if we have, for example, a curve, right, at this point here, if abscissa is a and if abscissa is a, uh, uh, if we go more near to a, like if we have here b, this will be f of b, right? This will be b, and this will be f of b on the y-axis. Linearization, it will be approximately equal, L of b, approximately equal to f of b. We can say here we have simply a delta f, right? Delta f between f of b and lb, right? An error. We have an error. It's not equal. It's approximately equal to this value. It's simply approximately equal to this value. Now, if we go further from a, the error will be more, right? And if we do more curve, if the curve is more has more concavity, right? Also the error will be more and more. Okay, uh, let's just take an example and try to solve it to know what's that mean. Let's say find the linearization of f of x, which is f of x equal 1 over radical x squared plus 1. Let's find at x equals 0. He has to give me at x equals 0, right? Let's find this linearization. L of x is f of a, right? We need f of 0 then. And f of 0 is equal to 1 over radical 0 squared plus 1. So it is equal to 1. And what else we need? This is f of a, this is f of 0, because a is equal to 0 over here. We need f prime of x, right? We need also f prime of x. It's not f prime of x, it's f prime of a actually, right? It is f prime of a, right? Okay, so we need also to find f prime of x. F prime of x, what is the derivative of this function, right? It's u over v, so it's u prime 0 over v u prime times v, 0, minus v prime, derivative of the denominator, is 2x over 2 radical x squared plus 1. It's u prime over 2 radical u over v squared, so over x squared plus 1. So the final answer will be of this minus x over x squared plus 1 radical x squared plus 1. This is f prime of x. What is f prime of 0 then? Substitute 0, 0, and 0 here. It gives me numerator 0 over 1 minus 0. It's 0. So we need this value of prime of 0. We need this value of 0. Again, let me find the L of x, right? He wants me to find the linearization of f of x. This means he needs me to find f of x, L of x, which is f of a minus f plus f prime of a, right, into x minus a. That's what he said over here, right? Let me take these values I need f L of 0, right, which is L of x, which is f of 0, right? F of 0 plus f prime of 0, f prime of 0 into x minus 0. So it will be equal 1 plus 0 into x, which is equal to 1. This is L of x. This is my L of x, right? L of x equals 0. Okay, again, in the same exercise, he wants me to use this linearization model, linear model of f to obtain an estimate for 1 over radical 1 plus, radical 1.04. What is 1 over radical 1.04? It's 1 over radical, simply 1 plus 0.04, which is 1 over radical 1 plus 0.2 to the power 2. What is 1 plus 1 over radical 1 plus 0.2 squared? It's simply f of 2, since f of 0.2, I mean, since f of x is what? F of x is equal to 1 over radical 1 plus x squared, or x squared plus 1. From the beginning, he gave me this x, right? This function, this f of x. Then this is the same like that, but replacing instead of x 0.2, we square it 0.04 plus 1, it's 1.04. That's great. What is that? What is that equals to? Simply, if we need to know how much is 1 over radical 1.04, it is equal to f of 0.2. And what is f of 0.2 equal? It's approximately equal to L of 0.2. And since L of x, if x is 0, is equal to 1, this means also this one, it will be equal to 1, because x approaches 0. 0.2, x is 0.2 is near to 0, right? So the answer will be equal to 1, with an error for sure. We have to put in our mind there is an error. I will explain about this error more in the Newton's method of linearization in the next video.